SwayamPrabha. Digital India. Educated India.
Welcome back. In lecture 15, we will talk about surface water intakes. The different concepts that we will cover in this lectures are on surface water intakes, sources of water supply, and state of water supply in urban India. So, intakes are structures which essentially consist of strainer. Strainer is sort of a screen, and within this through this the raw water from the river, canal or reservoir enters and is connected to a sump well by means of conduits. So, intakes are basic structures through which we actually draw water from different surface water sources, and usually the raw water is drawn, but it is taken through a strainer to prevent entry of impurities or bigger of particular bigger sizes. And then once this water is taken in, it is then sent to a particular sump well where it is first stored before it is pumped to a treatment unit or for other purposes, and this is connected by means of a conduit. Now, the actual location of this particular intakes for a particular stream, river, canal depends on many technical criteria, but from the planning perspective, I would like to say that intake should be located at a site where sufficient quantity of water is available even during worst condition. So, at least the general area could be determined, right. Then actual construction design has to be done as per different engineering design principles, but we have to find the most suitable location along a particular stream. So, it has to be located at a site where sufficient quantity of water is available even during the worst situation. It should be away from navigation channels and should be protected by a cluster of piles. If it's there are different kinds of intakes. Some intakes are built into the dams. Some in that case, this is not an issue. But some intakes are just put inside the river or a big lake. So these are independent structures, and we have to protect them. And sometimes we use piles to protect them. As far as possible from the sewage disposal, because there are continuous urban areas along a particular river body. So, there are disposals from different urban areas. We have to make sure that the intake for a particular urban area doesn't matches with or it is not near to a disposal of another urban area or from the same areas as well. In case of a meandering river, a diversion barrage should be constructed. So, in this particular image, you can see sort of a diversion barrage where some amount of prevention is there, so that water is stored. And why water is stored? So that you are able to get that water during the different seasons, even when the river meanders along its course. At certain times of the year, the water is not available in certain sections. So, a dam actually prevents that to happen. And also dam actually stores water when there is low water, then it actually ensures that there is some amount of water. So, it could be a dam, or it could be as in this particular case, in this particular image that you can see, it is just a diversion barrage where could be also constructed. This particular intake structures should also have sufficient cell weight to prevent the upthrust of water or current. Because of buoyancy, any structure that you build inside that river channel, it would be lifted up. So, it should have certain weight, so that that doesn't happen. So, this is what an intake is, and then there are different kinds of intakes. These are for surface water intakes. There are lake intakes, there are reservoir intakes, then there are river intakes, canal intakes, and so on. So, in this particular image, you can see some structures which are like these are sort of lake intakes, or like over here. You can see that this is a structure when there are certain equipment at the top, and this is a concrete structure which is going below. Now, lake intakes are of different kinds, like for example, you can have both the, like for in the drawing below, you can see that in this particular case, this is a pipe which is drawing water from the lake, this one inlet pipe, and this is just a structure which is below water level. It's a concrete, it's a submersible type structure, and it's and the pipe is of course laid in the bed of the river, and the pipe has got a bell mouth opening, and it is covered with mesh to prevent entry of impurities, and the surrounding is protected by a concrete or a timber shell, and which actually, you know, it's a sort of a cap which protects this entry, and from here the pipe actually is takes the water to a sump well or directly to a treatment plant, depending on the height of that particular treatment plant. So, usually it is taken to a sump well, from there it is pumped to a treatment plant, and that is what is shown over here. Like this is again, you can see it like the same thing you can see from another direction. So, this is the section. So, this is the maybe the pipe ends over here, and water enters through this particular screen, and when the water is transported, this is underground, this could be transported overground as well, and then this water is taken to a sump well which is at the bank of the river. This is the bank of the river, and there water enters and stored, and from here we can obviously control the entry of water using a slice valve. So, this is a slice valve over here, and this is the pump, and this pump actually draws water from this particular level, and this is a this is a strainer, that is, this allows only you know, the impurities, it is not allowed to go up, and then the water level reaches somewhere around here, because this is the water level in the river, and from here the water is actually drawn by this particular pump and then sent to a treatment plant. So, this is the reservoir intake. So, there is a dam at the back, you can see there are different kinds of reservoir intake. It could be either you know, a separate structure, or it could be a structure which is inbuilt inside the reservoir. Like in this particular image, you can see that the structure is inbuilt inside the reservoir. Like this is the you know, opening, this is the intake which this is that has been designed, and there are this kind of, you know, pipelines which allow entry of water, and there are different of these entry points, intakes, you know, this particular entry lines are at different levels. For example, to ensure that during summer water enters from this level, during other seasons, summer water enters from this level, during rainy season maybe water enters from this level. So, there is a screen, and this allows water to get inside, and then this could be actually, then this could be, these are valves. You can use valves to control entry of water, and once the water is stored, either then we can use a pump. Then this is the level, this is the pump over here, and this pump can actually draw water from this particular sump well, from where the water is actually stored, and then using this pump the water will be transported to a treatment unit. And for cleaning of this particular sump well, for at certain intervals, we have a withdrawal conduit like over here. There is outlet valve. Using this, we can also clean this particular well as well. So, this is how our reservoir our intake is designed. So, intake tower constructed within the reservoir in this particular case, and it could be also outside the reservoir. As you can see in this image, it is outside the reservoir, the intake towers, and intakes points, this kind of are fixed at different levels to draw water at different levels during different, you know, this is low water level, high, you know, this high river level. So, so this is the high water line. So, from here we so at different season we will use different intakes to draw water. Then this is a river intake. You can see the images as well. So, this is a river. This is the river intake which is constructed, and from there we can actually pump the water out. And so, this river intake over here, so this river intake is at the bank, roughly at the bank. It could be just at the bank, or it could be a little bit inside. Like if it is little bit inside, then there is a gangway over here, like you can see over in this image, there is a gangway. That means you can walk into this particular chamber, from where you can control the entry of water. So, these are the slice valves which allow entry of water. So, in this particular case, we are using one chamber. This in the first case, this is one chamber, and these are the intakes or the penstocks. This allows entry of water from below in most cases, and these are also fitted with screens, and then there are these valves which allow entry of water into this particular penstocks, and water is drawn from upstream side. So, in this particular rivers, it is usually drawn from the upstream side, and why? So that we prevent in the downstream usually we find all the sewage disposal points. So, it is basically better to take the water from the upstream side, and these are usually circular masonry towers of 4 to 7 meters in diameter at or near the bank of the river. So, either they are at the bank of the river, as you can see in this image, or they could be near the bank of the river, just a little bit inside. It is to ensure that at this intake always gets water. So, penstocks, these are the penstocks fitted with screens to check entry of floating solid and are placed at the downstream side. So, it is usually on the back side, that means water. These are fitted in such a way so that the direct water coming into this particular structure, this is not getting in, it is coming from the opposite side, the water is getting inside. So, in addition to this kind of river intakes, we also have got other structures like this is a wet intake, where we have got two cylinders, and for the outer cylinder is basically the one from where the water enters, and then we can control the entry of water from there, and then the inner cylinder we can allow, once the clean water is there, we would allow using the slice valves we can allow water to enter into the inner cylinder, and from there the water is transported. So, a concrete circular shell filled with water and openings for so this is a circular shell which is filled with water and openings for entrance of water both at inner and outer shell. So, this is the sort of intake which we usually see in again the design of these intakes are again there are different manuals or different engineering designs for each of these different kind of intakes. So, that is beyond the purview of this particular course. So, that is but what we will know that these are the different kind of structures, and these are the locations of this kind of intake points are there, so that we can draw surface water for treatment. So, similarly we have got canal intakes. In many cases we do not draw water directly from the river. We first draw water inside canals. The canals bring the water to a point from where the water is drawn through these intakes and then taken to treatment plants. And sometimes this kind of gates could be possible through which the water from the river gets into the canals, and then there are different canal intakes as well. And so, over here you can see this is the bank of the canal, this one, and we can fit a structure like this, where we have a chamber, and then we have this inlet structure which could be controlled by a valve, and this is again this is a bell mouth which covered with screen, and water enters into this particular structure and then gets through the bell mouth, and then it is transported to the treatment plant. So, these are simple structures that are used for drawing water from surface sources. Now, looking at the different sources of water supply in urban areas, there are both primary and secondary sources. For example, primary sources are rivers, ponds, lakes and tanks. It could be rainwater, it could be glacier melts, and it could be also groundwater, hand pumps, bore well, tube wells, covered and uncovered wells. So, these are the different kind of surface water sources that are used in urban areas, surface as well as groundwater sources, and it could be also sea water. So, sometimes like places like in some Singapore or places where like in UAE, we have seen that they utilize lot of sea water. They actually remove the salt and then they can actually use it. So, groundwater, sea water as well as direct rainwater, and of course, rainwater is not used directly, but after storing it and then after some treatment we can use it, and or for different of these streams like rivers, and then for ponds and lakes we can actually use this water. What are the secondary sources of water in urban areas? Canals, because river is the natural one, canal is artificial which we construct, and then dams along the rivers, bottled water, tanker supplies. Certain areas are supplied with tankers where there is not adequate water. Then tap water from treated sources and tap water from untreated sources. So, these are the different sources of water that we actually use in urban areas, and these are the secondary sources. So, these are direct sources and these are secondary sources from where residents get their water. Now, looking into the different river basins, this gives you an idea about the different river basins in India. Starting from Indus, then we have got Ganges and Brahmaputra, then we have Godavari, Krishna, Kaveri, Pennar, and on this side you can see the average annual potential in the river in terms of amount of water that is available in billion cubic meters, and then out of this how much water can be utilized excluding the groundwater part that comes into the river, that also given in billion cubic meters. And we can see that this is the amount of water. For example, you take Ganges, 525 billion cubic meters of water is available. Out of that we can actually utilize 250 billion cubic meters. And then take another example, like for example the Tapi river, around most of the water is available for use. So, this is how we can actually determine the different surface water sources and the other sources that are there in an urban area. So, once we know the intake points for the different rivers, for each river we can set up intake points based on the need, of course. Like for the example, there is an urban area, we will first we will determine what are the nearby sources. Is it a pond, is it a lake, or it could be a combination of a river, a pond, a lake, and so on, and then we can determine where we should put on the intake points. And as you can see, we have shown you the different kind of intakes, both groundwater intakes as well as surface water intakes. Groundwater intakes could be like tube wells and all. So, we have to determine on a mix of these sources for an urban area. So, not all water is available from maybe I am in a river where very little amount of water is available. So, I have to depend on other sources as well. So, we have to design a mix of all these different sources for an urban area. To see the status of water supply in urban areas, we have discussed this to some extent also, and where we see that as per census 1991, 2001 and 2011, what we see is like improved sources of drinking water. This is there are different ways how you define improved sources. Like in 2001, the definition was different from 2011. That's why you see a difference in the values. But roughly what we see, there is water from tap water, there is water from well water, and then there is hand pumps and tube wells. So, this is the the other part. So, in census 2011, you can see hand pump tube wells around 20.8% and covered well around 6.2%, and total tap water was 70.6%. Out of that, 8.6% was not treated and 62% was treated. So, total improved source was estimated to be around 89%, right. So, this is for drinking water in case of India. Then within that, within urban areas also, there are also difference of access to water. And as we can see that in urban areas, there are slums and then there are non-slum areas. So, definitely we can see that the percentage of households using tap water in slums is sometimes over here within premises. This is the total water that is being used, and then in within premises we can see that around 45.6% of the slum dwellers and 55.9% of non-slum dwellers have tap within their premises, and near premises 23% of slum dwellers and 11.2% of non-slum dwellers use water from near premises, and from away from their premises we can also see these percentages. So, access to water is also not uniform all throughout. So, most access to slums are from stand post and individual connections, and many slums are not notified by the government. Thus, individual connections cannot be given to this particular slums. So, these are some of the challenges that are there in urban areas which we need to overcome when we determine supply of water to a particular urban area. So, first we determine what sort of intakes are there, and then from there of course, we will do treatment, we will do the distribution network, which will be taken care of in other lectures. But we need to determine what could be the sources, but if it is groundwater sources, it could be also some real estate projects or some buildings could have groundwater sources even inside their premises as well. Otherwise, we can also, as you can see from this particular figures, we have got this is the status currently in India, and we are trying, and the current government is also working on schemes to provide tap water access to all families and all households in the entire urban areas. So, state of so then looking into the different service level benchmarks, and this is the data. This is a study from 2011. It was found that for different categories of cities, class 1, this is 1A, 1B, 1C, then 2, 3 and 4, these are the different categories of cities. We can see that this percentage of connections in urban areas, we can see that average national is around 53.3%, whereas per capita LPCD supply is 70 LPCD. Metering is almost negligible. Non-revenue water is around 30%. That means this is unaccounted water. That means this water is either getting lost or stolen. And continuity around average hours per day supply is around 2 hours per day. The quality and treatment, around 95% of the water is actually treated, and customer complaint around 75.76% of the customer complaints are redressed, 33% of the cost is recovered, and efficiency in 65% of the billed water is being, you can collect charges for those. So, this is the efficiency of collecting of charges. So, you can see that this percentages vary in the different classes of categories of cities, and this vary significantly. For example, the range starts from around per capita supply starts from around 110, 12, or this, these are more or less similar categories, and then it ranges to at least 70 liters per capita. So, there is wide difference. Similarly, coverage in connections, roughly some cities, some category of cities, it was observed to be around 46%, 45%, which is pretty low. And similarly, for metered connections in major cities, we have got around, some cities have shown around a lot of percentage has been covered through metered connection, but in many cities it is not there. Quality of treatment more or less similar, redressal of customer complaints similar. Cost recovery, you can see that the lower the category of the cities, the cost recovery is even less. So, in some higher order cities, we have got full cost recovery. In other cities, we do not have. Now, similarly, efficiency varies from around 60 to 70%. Now, this data is based on 1493 cities across 14 states. So, it is not the national average of all cities. So, it is average of certain cities, and this is data is also for 2011, but this is to give you an idea about what are the different parameters and what is the status of water supply in urban India. So, to conclude, intakes are the starting point of water supply systems. So, this is what we have to determine the locations or suitable locations for setting up the intakes, and location of intake should be near the treatment plant to reduce cost of conveyance as much as possible, but it is not always possible. Sometimes the treatment plant is far away from the intake point, and slum should be given equal importance while planning for water supply in urban areas, because poor people are the most vulnerable, and because we are not providing water supply either because of legal reasons or because of technical reasons directly into the, tap connections into the streams. So, tap connection into this particular slums in this particular, so that has to be actually that leads to a lot of coping charges for the slum dwellers. So, this has to be taken care of. So, these are the references that you can study. Thank you.